So today's lesson we're going to learn how to write the formula name and how to write out our formulas for binary compounds. So binary means two compounds. Let's go through the vocab word of compound. We've been focusing on molecules, and let's now learn this new vocab word. The word compound, I'm going to write this on the top. In particularly, I'm going to write the word ionic, so making an ion, which we learned from Unit 1 and 2. When we have an ionic compound, we have a metal and a non-metal. So what you should have out is your periodic table so we can refer back to it. Remember that the trend on the periodic table, everything left of the stairwell, the darkened steps, are metals, and then everything to the right are nonmetals. We focused again from nonmetals, which are called molecules, and right now we're only dealing with ionic compounds. So the first thing you need to do is identify that it is in fact an ionic compound, a metal and a nonmetal. Before we do that though, we do need to refresh ourselves with the trends on the periodic tables of how we ionize. So looking at the periodic table in your column 1, your hydrogen, lithium, sodium, potassium, and so forth, you need to remember that there is one valence electron in that last outer shell, the valence. All the atoms on the periodic table, its goal is to be more of the electron configuration of a noble gas. If you have one electron in the valence shell, it's easier for it to get rid of that one electron and become more like a noble gas configuration, electron configuration. So therefore, because it loses that one electron, losing an electron, which is negative, becomes a positive 1 charge. So everything in that first column is positive 1. If we look at the alkaline earth metals, group 2, they have 2 electrons in the valence shell. So therefore, it's easier to lose your 2 electrons, negative electrons, becoming a positive 2 charge. And then you encounter the transitional metals. The transitional metals will run all the way up to the stairwell. So their trend is something that you need to actually memorize, and it's not a trend of the charges. And this is why you had to memorize that worksheet that I'd added to the polyatomic and ion worksheet. Some of them have more than one charge applicable, and we'll be able to go further into that in another lesson. So looking at the right side of the periodic table, we now have our nonmetals. So group 17, starting with fluorine. It has 7 electrons in the valence shell, so it only needs 1 electron. When it gains that electron, it's gaining a negative electron, and it's gaining 1, so this is why it's considered a negative 1 charge. Your group with oxygen needs to gain 2 electrons to be more like a noble gas configuration, and therefore it's a negative 2 charge. Nitrogen would be negative 3 charge. The carbon and silicon would be negative 4 charge. Again, tin and lead are germanium. Those are ones you memorize. So using that information, we'll now learn how to write our formulas and write the names of ionic compounds, in particularly binary, 2 atoms put together. So first let's identify sodium. Sodium's on the left side of the periodic table. Its symbol is Na, so I'll write that information there. We do know it's in group 1, so it is a +1 charge. I'll write that information there as well. Note that sodium is a metal. So when we have all of our atoms and different types of compounds and molecules and acids on one worksheet, the first thing you should do is identify what that actual formula or compound is. In this case, we have a metal, and then we have something called chloride. So the formula name of that, you'll notice that the ending has been dropped and IDE has been added. The ending would have been chlorine. So chlorine, I'll write a Cl. Chlorine is found in the 17th group. Going down, it's got 7 electrons, needs 1 more, so it's a negative 1. This is a nonmetal. So I'll put N on the top. You'll notice that this entire worksheet is dealing with ionic compounds. However, I want you to be able to identify on an ionic compound a metal and a nonmetal. 2 metals put together are not ionic compounds. You must start with a metal, start with a positive metal and a negative nonmetal. And when I say by positive and negative, it's because the positive charges go to the metals and nonmetals have negative charges. There's a vocab word that's associated with that, so I'm going to write that on top in a different color. Nonmetals are negative and they're known as anions. So anti is a prefix, so anions is negative. Those are negatives. And metals, I'll write right here, are called cations. That little T is going to indicate that it's a positive. It's just a way to remember the vocab word. So back to sodium chloride. You'll note that that was a chlorine atom. I have my charges written there. I'm going to show you a simplistic way to write the formula. With the charge information, we're going to circle just the numbers, and we're going to crisscross the charges down. So my final answer for sodium chloride is NaCl. We do not need to rewrite the number 1 because by putting a symbol of Na, that's indicating we have 1 atom of sodium and 1 atom of chlorine. All right, let's go further down and find another example. I'm going to do strontium chloride. So look at the name strontium. It's capitalized in the writing. The first word, it's an entire form. Strontium is Sr on the periodic table. It's in the second group, alkaline earth metals, and it's a +2 charge. Note the second portion of the naming is lowercase. The ending has been dropped, but the name was chlorine. From our previous problem, we remember that chlorine is -1. If we look at the periodic table, it's furthest to the right before the noble gases. I'll circle the values, the numbers only, not the charges, and I'll crisscross. There is a reason you're able to shorthand and make the formulas work this way, and I will show you why, the reasoning why, when we're in class Thursday and Friday. We'll rewrite that, SrCl2. Again, we don't need to reiterate the 1 next to Sr, and the Cl2 means we have 2 chlorine atoms. I'll do one more. Let's go down further to sodium selenide. So sodium's written its entire name. It's capitalized, lowercase the second name, and drop the ending. So let's look up sodium. Sodium is Na, +1 charge. Write that out. Selenide is an Se, and it's a -2 charge. It's found in the oxygen group. Again, I'll circle the numbers so I don't bring any charges down in the subscripts, only the value, and I'll rewrite it. Na2Se. And again, you don't need to put the number 1. It's indicated by writing the symbol itself. So let's see, if we were given an actual formula, how can we write the name? And we've been practicing the opposite way. So let's start with this. Sr is strontium. It's a metal, so I'm going to write that in its entire name. And you know the second one is nonmetal, so look on the right side for nonmetal. And you'll notice that this name is sulfur. Now you typically would think we'll drop the 3 letters and add IDE. However, with practice you'll find that there are some errors if you do that. It's not always as drop 3, add IDE, because this would be solide, but in fact we do keep the F and just add IDE. Let's do another one. Let's do this one, Mg3N2. Note that it does not matter those subscripts in the naming of this because we're dealing with 2 atoms, binary atoms. The subscripts were there just because they were charges. The N had a -2, excuse me, and the magnesium had a +2. That's where the charges came from. In the naming, we just write down the entire name. So magnesium, and N stands for nitrogen, but we shorthand it, lowercase. Nitrogen has an ending of nitride. So this binary compound, ionic compound, is known as magnesium nitride. So now I want you to practice the rest of the worksheet and check your answers with the key.